viewers, you are welcome once again to Ojemai TV. Today we will be looking at electronic configuration of elements. In electronic configuration of elements, in our previous video we have already done electronic configuration, but here we are going to look at the one of nitrogen and nitride, bromine and bromide, phosphide and phosphorus. They are different because in nitrogen we have nitrogen as we are looking at nitrogen itself and nitride. Nitride is the one that carries charge. Anytime you see idea, like in the case of nitride, you see in the case of bromide, you have charges in it. But in the case of bromine here, you are just looking at the simple element. And before doing that, before looking at the electronic configuration of this, you must first of all understand the basis of these rules. In the electronic configuration, we looked at the SPDF, and in the SPDF we looked at the full meaning of SPDF, which is sharp, principal, diffusion, and fundamental. Sharp, principal, diffuse, and fundamental. In arranging it, you have to arrange it in order for you to be able to know exactly how these things are written. You have to arrange it this way. First of all, write 1 to 8. When you write 1 to write S all, that is the first principle. Then the second one, right from here, don't start from the beginning, start from the number 2, write 50, from 2 to 7, then write 50 all. Then the next one, write D, like in the case of this one, you have already seen it in the board. And one thing you have to know, I've already mentioned it in my previous video, that the S here, the S orbiter here occupies or carries the maximum number of 2 electrons. That is the number of electrons that is there is 2. It can carry 1, it can carry 2, but it cannot carry more than 2. B here carries 6, while D here carries 10. It can, of course, it can carry 1 to 9, and it can also carry 10, but it cannot carry more than 10. We also looked at that F here can carry from 1 to 14, but it cannot carry more than 14. So we now go straight to the point looking at the electronic configuration of nitrogen. In nitrogen, you should know that nitrogen has atomic number of 7. Nitrogen has atomic number of 7. And when you are writing electronic configuration of nitrogen, you first of all start with this one. We have 1s. You have 1s, and I told you that the s has the maximum number of what? 2. You have 1s2. The next one you have 2s. You have 2s, and s carries the number of what? 2. You are looking at 7. Then the next one is 2p. You are looking at 1, 2. That is the way you just come here. When you finish with this one, start from here. When you finish with this one, start from here. Come like this. That is how this arrow are pointing. You don't come and say because 4 here, because 3 here, you come no. If you do like this, if you go into the straight line, you are missing it. So the best you have to do is to pass like this, and come back like this. It's not for you to go straight. Just pass the way the lines have been drawn. Then after you have 2s, the next one is what? 2p. You have 2p. And I told you that the maximum number of p carries the maximum number of 6. So I mean, I just left to complete this one. We have 4. So this is the electronic configuration. So 3. This is the electronic configuration of nitrogen. What about nitride? So we want to look at the electronic configuration of nitride. In nitride, you should know that nitride, this is the what we mean by nitride. Nitride has a charge of 3, -3. So now this -3, now you are now adding it to the original nitrogen, because nitride is coming from nitrogen. So you now have nitride as equals to what? 10. You are now writing the electronic configuration of 10, just like the one of neon. But here, because it is nitride, you are adding 3 because the oxidation number of nitrogen, when it's combined with any other element, is equal to give you a -3. So when we are writing this one, you first of all, of course, you know that you start from the beginning. You have 1s2, 2s2, 2p. P carries the maximum of C, so you put C. So 2 plus 2 will give you 4, plus 6 will give you what? Will give you 10. That is how to write the electronic configuration of nitrogen and nitride. Just take a look at it. We'll now do the next one. So in bromine here, bromine has atomic number 35. Atomic number what? 35. While bromide while bromide has atomic number 36 because bromine belongs to group 7 of the periodic table, and the group 7 of the periodic table has a charge of -1. So you are adding 1, so it's like you have bromide. This is how it is written. So a charge of you. We already talked about the oxidation number in our previous video. So we are going to look at the electronic configuration of this one and bromide. So in bromine, we will start from the beginning. We have 1s2, 2s2, 2p6, 3s2. Look at 1, 2, 3. We are looking at 35. So we have 3s2, we have 3p6, we have 4s2. When we look at 4s2, we now look at this 4s2. The next one is, we now go here 3g. G carry the maximum of what? 10. So 3g. We are looking at the total of this one is 2 plus 2, we have 4. This is 10. This is 20. This is what? 30. We are now looking at the next one. After D, we now look at 4. So 4p. We carry the maximum of what? The maximum of 6. So we are looking at 35. This is 30. So this is 25. So this is the electronic configuration of bromine. So when you are writing bromide, now bromide is now 36. So what you have to do is still keep on doing the same thing. Now will now be 4p6. So that is the electronic configuration of bromine and bromide. Bromine, because of the charge, you are adding one to it. So let's look at the one of our phosphorus. Phosphorus is now very easy. If you have followed the rule, it's very easy for you to get the one of our phosphide and phosphorus. In phosphorus, you should know that phosphorus has atomic number 15. I will do the one of phosphide while you do the one of phosphorus. Why? Phosphide has atomic number 18. Right? This one is because of the charge. P minus 2, so you have what? 15, 18. So you are adding 3 to this one to get what? 18. So I'll do this one. Now why you do this one for your last one. So we look at it, start from the beginning. From here to here, here to here, here, and so on. So we start from 1s2, 2s2, 2p6, 3s2, and 4, 3s2, and 3p. So P3 we have 2 plus 2 give you 4, plus 2 give you 10, plus 2 give you 12, plus 6 will give you what? 18. So this is the typical electronic configuration of phosphorus. I believe you understand. So what you are going to do is you try this one on your own and subsequently try the one different electronic configuration. So if you are given electronic configuration of ion, is different from a normal electronic configuration of any of these elements. Like this one, nitrogen nitride. This one is ion. You understand? Like this one we have ion N3 minus. While this one we have bromine minus. This one we have phosphorus. Of course, this one 5 minus 3. That's how it is. Thank you. We'll come to the end of our class today. Remember to subscribe to Watch My TV. Any question you have, drop it in the comment section. I will attend to you. Thank you and God bless you.